Hello, here we will discuss about the determination of the transfer functions from Bode magnitude plot, right? That means Bode magnitude plot will be given to you. You have to calculate the transfer functions corresponding to it. So that is our purpose. Only Bode magnitude plot will be given to you. No phase plot is required to get it. So whatever the rules we have learned, that kind of rules will be applied in reverse order to get back the transfer functions, right? So let me discuss the steps, all the steps, step by step. See, this is your magnitude graph is given to you. Now, once the magnitude graph is given to you, definitely the slope corresponding to each of the straight lines, that is asymptotic straight lines, will be given to you. Here, you see, this is a straight line minus 20 dB per decade. This is a straight line 0 dB per decade. That is a line having slope of minus 20 dB per decade, and there is a line which is having slope of minus 40 dB per decade. And you see, we know the definition of the corner frequency. We know the definition of the corner frequency, and corner frequency plays very important role. What is the corner frequency? That means two slopes meeting point, we can say it, right? That means the two straight lines of defined slopes will meet together at a point. That means what are the defined corner frequency we'll get from here? First of all, identify the number of corner frequency first. So number of corner frequencies. What are the number of corner frequencies we'll get? See, minus 20 dB to 0 dB. So 1, next 0 dB to minus 20 dB. Here is the corner frequency. Here is a corner frequency. You get the frequency from frequency axis, and here also there is a corner frequency, right? So how much times the slopes been changed, right? So this is 1 and this is, so from minus 20 dB to 0 dB there is a corner frequency. So total number of corner frequencies 3. That means if there are 3 corner frequencies, what are you will getting? Time constants. So 3 time constant you will get, right? 1 you will get 3 time constant. That means 1 plus st form you will get 3 such form will be given, that means obtained depending upon this time constant, because this time constant is equal to 1 by corner frequency. That is your rule, already we have discussed. That means what should be your key frame in your mind? That means based off in this graph given to you, you have to identify what are the number of corner frequencies given to you, and that corner frequency can be identified from the graph itself. Now once you get the corner frequency, you will get the corresponding time constant by inverse of it. Once you get t, that means that will be factor 1 plus st. Okay, now this is clear to us till now. Now what you have to find out next, one important thing is that you have to find out whether the system is type 0 or type 1. That is a very crucial point, and you see in everywhere when you have solved the Bode diagram analysis, so type of the system was very important. Type of the system. So how the type of the system affects the Bode plot? See that type versus slope, initial slope, right? One table I have already discussed. What is the initial slope? Initial slope, if that is 0 dB per decade, so this is a type 0. Initial slope minus 20 dB per decade, so this is a type 1 system. If the initial slope minus 40 dB per decade, that is a type 2 system, and so on. So from this Bode magnitude plot, what you can see here, initial slope, this is your initial slope from the initial positions of the frequency. Here they have considered the initial frequency 1 radian per second, and 1 radian per second, what is the magnitude? 40 dB. So that will be given to you. Now your idea is that what are the different kinds of or the type of the system will be obtained from this. Say initial slope, here you see clearly it is shown, it is minus 20 dB per decade. So initial slope in this case is minus 20 dB per decade. Here you can it is clearly seen that the initial slope is minus 20 dB per decade. So according to this structure, so definitely this is a type 1 system. Say observation number 2. So first of all, you have to consider or find out what are the number of corner frequencies, and next what is the time. Once you get these two idea, definitely the part of the game is over, right? How? That also. See, we will make a table like this. How can you make the table? Table can be made in such a way so that just you see what is the table. Table means uh, frequency. Next we will get like uh, slope change, slope added to frequency. Just a tabular form we will represent it. What is the frequency? See, this frequency, that is omega is equal to 10. So this is omega is equal to 10 radian per second. At this frequency what will get, the slope is changed from minus 20 to 0 dB, right? Minus 20 dB per decade to 0 dB per decade. So what is actually slope added to this part? What is the slope added here? What is the slope added? Plus 20 dB per decade. Definitely, mine at omega is equal to 10, you have added a slope of plus 20 dB per decade to get the slope 0 dB. That was the procedure of followed. Right. Next, corner frequency of already identified. What is this? Say this is 50. So at 50, that is a corner frequency because there is a slope change. And see, the slope change from 0 to minus 20 dB. So 0 to minus 20 dB means what is added with the 0? So minus 20 dB per decade. Right? So at omega is equal to 10 corner frequency, slope contribution is plus 20 dB basically. Right? So at omega is equal to 50 radian per second, basically what is the slope contribution? Minus 20 dB. And see another corner frequency, omega is equal to, say this is 300. What is the change in slope? So minus 20 to minus 40. So minus 20 is added with minus 20 dB to get the minus 40 dB slope. So again minus 20 dB per decade. So that is the concept we are getting from this that's Bode magnitude, nothing else. But you have taken, if there is any change of slope, so that gives you corner frequency. That can be identified and you can write it as it is frequency. Now what happens in this frequency, you see this is the change of slope from minus 20 dB per decade to 0 dB per decade. That means what you have added here, actually during the Bode magnitude plot drawing, what you have done that what is the contribution at that particular corner frequency. So in reverse way, you can say at omega is equal to 10, change of slope is from minus 20 to 0 dB. That means plus 20 dB is added with minus 20 to get 0. So plus 20 dB per decade is the slope contribution here. So at this frequency, what you have contributed? Plus 20 dB per decade. Similarly, at omega is equal to 50, what you have contributed? That is minus 20 dB per decade. And at omega is equal to 300, what you have contributed? You have contributed minus 20 dB per decade again. And what does this actually signify? That means if you contribute a slope of plus 20 dB, that means there is a 0, right? Plus 20 dB you are contributing, that means you are adding a 0 there, right? You are adding a 0, and you see this is minus 20 dB per decade. Once minus 20 dB per decade is contributed, that means there is a pole, single pole, and again the contribution is minus 20 dB per decade. So this is again a single pole. Now your work is almost over. What is that? That means at this corner frequency one 0 is there, at this corner frequency one pole is there, at this corner frequency one another pole is there, right? And if you get this corner frequency corresponding to that, you will get the time constants. So what are the defined time constants we will get? We will just get the time constant like T1, T2 and T3. We will say it like, say for example, you can say this is your omega 1, omega 2 and omega 3. So T1 equal to 1 by 10 T2 is equal to 1 by 50 and T3 is equal to 1 by 300, right? These are the different time constants you get. Once you get the time constants, what are the factors you will get, right? Next I will just write other, remove this part. We can remove this part, right? A part of it I can remove it. You can have the data with you. Now the thing is that you get corresponding to this T1, there was the T1, so 1 plus is by 10, that is the factor. But this corresponding to this factor is 1 plus is by t. Next, this will give you factor of 1 plus is by 50, and next 1 plus is by 300, right? Now see. So 1 plus is by 10, that comes from the corner frequency. Now this is contributed due to a factor 0. That means this factor will be on the numerator part. This factor is for pole. Pole means you will get it in the denominator part, and so on like this. So I will write all these factors here. So what is the standard form of transfer functions? You know all these things. That is gs equal to, we can write k into, k is the gain, generalized gain, and we will find out how to get the k from this given figure. Now k into, see, 1 plus s by 10, this is a factor which is for 0. That means on the numerator you will write 1 plus s by 10, right? And next two poles, 1 plus s by 50, this is the factor which is for pole. Pole means in the denominator, that factor will come into the denominator. Second, there is again one pole, and that factor 1 plus is by 300. So this is 1 plus is by 300, right? So these are the factors we are getting from all this corner frequency related. Now coming to the part where we have discussed, this is a type 1 system. Why this is a type 1 system? Because there is initial slope of minus 20 dB per decade, we can see from here, right? So as this is a type 1, so this is a type 1, again I am writing type 1 system means s is equal to 0, 1 pole. There is a single pole at s is equal to 0. So what will be the corresponding transfer functions? So transfer functions is like this. Now your transfer functions is almost ready. Got it? So s is equal to k into 1 plus s by 10, s into 1 plus s by 50, 1 plus s by 300. Okay. Now what is the value of k and how to get the value of k, right? So for that, what you have to find out, I will just write two steps. One is that you have to find out the magnitude at initial frequency. To find out k, what we'll do, we will find out magnitude at omega is equal to, that is at initial frequency, whatever may be the initial frequency in the graph, you can see it. Next, find out the magnitude at immediate next frequency, right? Here first of all we will find out these two. But so what you will get, you will get, see, magnitude at initial frequency. What is the initial frequency here? Omega is equal to 1. It may be 0.1, it may be 1, it may be 0.001, whatever. At initial frequency, what is the magnitude? 40 degree. So initial omega, initial 40 degree magnitude, right? Next, immediate next frequency. What is the immediate next frequency means? Next, I can say it corner frequency. I can say it immediate next corner frequency. Immediate next corner frequency. So immediate net corner frequency is 10. So what is the magnitude here? At omega is equal to 10, you will be having magnitude 0. Sorry. this corresponds to 20 dB. Got it? So here you will see this is the immediate next corner frequency. Immediate next corner frequency is 10. This is your initial frequency. At initial frequency magnitude is 40 dB, you see, and here at immediate next corner frequency what you will get, that is your magnitude 20. So these are the two factors we are getting. Now once you get this, next just put a formula like here I will write this term, right? See, this is your 20 log k is equal to magnitude at omega I minus magnitude at omega IC. Right? So 20 log k is equal to magnitude as omega I, that means initial frequency, and omega IC immediate next corner frequency 20 dB. Here according to this procedure you just put these values there, 40 minus 20. So what is your expression you are getting? That is 20 log of k is equal to 40 minus 20, that means 20. So log of k equal to 1. This is always base of 10. This is always base of 10. That means k equal to 10 to the power 1. So 10. What is the value of k you get? 10. Now see what is your ultimate transfer functions you will receive. Finally you obtained, that is gs equal to, you can write here, that is gs equal to 10 into 1 plus s by 10 by s into 1 plus s by 50 into 1 plus s by 300. Right? So this is the concept how you can get the transfer function for the given Bode magnitude plot. Right? Any kind of transfer functions will be given to you, and from that you can find out the transfer functions by applying this concept of basic rules. Right? So this is the end of determination of transfer function for Bode magnitude plot, and also this is the end of your Bode, I can say the Bode magnitude Bode plot at analysis, frequency domain analysis. And in the next class we can follow such that in the next class the another frequency domain analysis tool will be discussed, that is very important too again, which is polar plot and Nyquist plot for stability analysis in frequency domain. Right? So in the next class, next series of lectures we will deal on that. Right? Thank you.